Hi, my name is Kabeer Kwatra and my student ID is 800046988.
Hello, my name is Janmesh Nashikkar and my student ID is 800047111.
Hi, my name is Rudraksh Mehta and my student ID is 800047075.
Hello everyone. Today I will be demonstrating the foundational steps of building a public key infrastructure or PKI model. My objective is to establish a root of trust and verify request for a service certificate. This process involves two main tasks: creating a self-signed root certificate and verifying that certificate for signing request. Now we will start with task 1. That is, we have to create a request. To generate the root CA, I used single OpenSSL command. This is powerful because it does two things simultaneously. It generates a 4096-bit RSA private key, which is our root CA key, and it uses that key to create a self-signed certificate, which is root CA certificate, which is valid for 10 years. And here we can see the output of that. Our root signed certificate is has clearly prepared and it is running. It is showing CA that is true, and signature algorithm has given us a SHA-256 key encryption as well, and we got the signature value as well. So task 1 asks us 3 questions. The first question is that what indicates that this is a CA certificate. So here, as we can see, it shows CA that is true. So when we look at the extension specifically under X509v3 basic constraint, it shows CA2 true, which is the digital badge that gives the certificate the authority to sign others. Without this is just a regular certificate. I'll move on to question B, which asks that what indicates that this is self-signed. Since this is the root, there is no one about it to sign it. If we compare the issuer field and subject field, they are identical. The neutrum CA is vouching for itself. Finally, question C concerns the RSA mathematics. The certificate is public, but the math lives in the private key. Using the RSA text command, we can get raw components that are modulus, public exponent, and private exponent. Modulus is our n, public exponent is E, which is standardly 65537, and private exponent is D. And finally, we get two large prime numbers that are P and Q, which generated the modulus. Moving on to task 2. The task 2 is verifying the request. We shifted from root CA to server side. Before we sign any certificate, we must verify the certificate signing request, which is CSR, to ensure it is asking for the correct permissions. Modern browsers require a certificate to be valid for multiple names, not just one. This is handled by the subject alternative name, which is SAN. I ran a verification command specifically filtering for the SAN. As you can see in the output, the request successfully includes 800046988.com DNS, which is other DNS, which is www.example.com, and the third DNS, which is www.bank32.com. In conclusion, I have successfully established the NetRAM root CA with the correct basic constraints to act as a trust author, and I have verified that in the incoming server request contains the necessary subject alternative name, which has SAN for multi-domain support. We are now ready to sign the server. Thank you.
Let's move to task 3. Now I'm going to show how to secure a website using HTTPS with Apache. And now we are going to use our own certificate authority, or we can say CA, to create a certificate for our server. First, we have generated and signed the certificate, and then we act as our own CA and sign this request to generate the server certificate. After that, we check the certificate to see if everything is correct or not. In here, you should be able to see the website domain under the X509 version 3 subject alternative name. This means the certificate is ready. Here I have highlighted the domain name of our website. So let's move on to task 4, in which we deploy the certificate on Apache server and configure the Apache to use this certificate and serve our website over HTTPS. Here we have created the folder in which there are two files, which is server.crd and server.key. Next, we will open the nano editor to see the configuration of virtual host. And in some simple terms, virtual host is like a set of instructions for Apache, which tells us what kind of files Apache need to use. Here we have, we can see the server name, which is I have highlighted, and the name is www.800046988.com, and the document root is the folder where our website files live. Okay. Now these are the files that we have talked earlier. Now, then the next step, we will open the website on our browser. As you can see, here we are getting the warning because we haven't uploaded our certificate, which is signed by our CA. So next we will importing our CS signed certificate in our browser, and then we will see what will happen. So now we are doing that. So after uploading that certificate and reload the browser, we are able to see our web page of our website. So we can say that we have successfully created a server certificate, deployed it on Apache, and our website is now running on HTTPS. All the traffic between the browser and the server is encrypted and secure. Thank you.
Let's move to task 5. Our goal in task 5 is to demonstrate a man-in-the-middle attack. We are going to use the configurations of the previous tasks, but we are going to make a few changes in it. First, we are going to start by doing DNS cache poisoning attack on the victim machine. So here I have opened the etc host file, and I have added, or rather uncommented, a line which points the IP address of our attacker machine to www.example.com, and I'm going to save it. And so when our victim machine searches for www.example.com through DNS, it's going to point it to our attacker machine. So next, I'm going to show you the certificates that I've added on our web server. Here, as you can see, that the server.crt and server.key file are still present at the etc apache 2 SSL folder. So now let's have a look at our configuration file, default ssl.conf. As you can see that I have added another block of code, which is basically the virtual host configuration, which points to the server name www.example.com, and which opens up the document, which is by default in our HTML folder. And it also points to the SSL certificate files, that is server.crt and server.key. All this is done. So now let's have a look whether our attack worked or not. Here I've opened up the victim machine and I've opened up a browser, and I'm going to access www.example.com. And as you can see that it leads to the same website. This attack can be used to mimic or act as a trusted website, like a banking website or a social media website, and the attacker can extract the information which the user thinks is going to a legitimate source. So now let's move to the final task, the task 6. Our goal here is to demonstrate a man-in-the-middle attack on compromised CA. So we are going to assume that our machine, which has the certificate authority, has been compromised. In this task, we are going to assume that this machine has been compromised, which hosts our certificate authority, and we are going to act as the attacker and generate some certificate files for our fake website, which we are going to use for the man-in-the-middle attack. I have already generated certificate files for the domain facebook.com, and as you can see, this file facebook.csr, that is a certificate signing request, points to, or the subject alternative name inside it points to the DNS www.facebook.com and just facebook.com also. So we are going to use facebook.com as our fake website. Let's move to the web server and see our configuration. As you can see that we've already added facebook.crt and facebook.key certificate files inside our Apache SSL folder. Now I'm going to show you another virtual host configuration block that I've added for facebook.com. Here the server name points to www.facebook.com and the certificates are facebook.crt and facebook.key. So now let's see whether our attack works or not. Before that, we also have to do DNS cache poisoning for facebook.com. So let's go back to our etc host file. And as you can see here, I've uncommented the line which points the IP to the DNS www.facebook.com. I'm going to save this. And now let's try opening facebook.com. As you can see that when we load up facebook.com over the HTTPS connection, which is supposed to be secure, we are taken to our fake website. This website can be used to extract information of Facebook.com users' credentials. And this can also be used to fake many other websites, like a banking website or a payment gateway. We can see that what the extent of a certificate authority being compromised can be. It can lead to large-scale effects and loss of both financial and reputation for trusted websites. That brings us to the end of this presentation. All our tasks have been accomplished and demonstrated. Thank you.